Hi, I'm back to show you how to predict what's going to happen with this cell once it's connected. Okay, so we already know that electrons are going to flow from anode to cathode. I'm going to show you how to determine which one of these is the anode and which one of these is the cathode. All right, the process by which electrons are produced and flow is a redox reaction, and we already know how to predict a redox reaction. We just need to find our SOA and our SRA, and we do that with our redox table. Okay? I'm going to link the data booklet into Google Classroom if you've lost yours. And I'm also going to leave some in the classroom because you will have access to the school shortly. Okay, so I hope you remember the process. We're looking for our SOA by starting on the top left. Okay, and you just go down until you find something we have. I can peek at it. It's coming. Copper 2 ions. Okay, that's what the copper electrode is in. That's going to be our SOA. Let me write that down. Okay, so let's continue the process. Look for our SRA. Okay, I know you guys have been off for a long time, but hopefully remember zinc is a strong reducer. Sorry, a strong reducing agent. Okay, so that's going to be our SRA. So I write this half reaction left to right. Okay? So that's telling us that this zinc electrode is going to lose electrons. Where do those electrons go? Through the wire to copper. And into the solution, the copper 2 ions pick up those electrons and become solid copper. Okay? So just to go through that again, solid zinc is oxidizing, becoming zinc ions. Okay, so it's going to increase the concentration of the zinc ions, but the solid zinc is going to corrode, it's going to oxidize. Okay, as it does that, electrons move to copper that are picked up by the ions, and this copper electrode will actually grow. There'll be more copper formed on the surface. In order to keep this reaction happening, the salt bridge releases ions into the solution it's in contact with. Okay, so the salt bridge, typically there's little cotton balls here, so the liquid doesn't just flow out immediately. But what happens is this half cell is gaining electrons. So it's becoming negatively charged. Okay? In order to balance that, the salt bridge is going to pop some positive ions in. Okay? The positive ions from the salt bridge are going to be attracted to this half cell because it's becoming negatively charged. Similarly, this half cell is losing electrons. That means it's becoming positively charged. All right? The salt bridge includes anions as well, so negative ions will leave the salt bridge into this half cell. Okay, I want to make that more clear. So I'm going to say positive ions leave the salt bridge into this side, negative ions leave the salt bridge onto this side. And again, that's just to balance the charge that's created via the transfer of electrons. Okay, so again, the role of the salt bridge is to balance the charge of each half cell. That's going to be a question on an assignment sometime. Without the salt bridge, once redox occurs and there's an imbalance of charge, this half cell is negatively charged, electrons aren't going to go through the wire because they're going to be repelled by this half cell. The salt bridge is absolutely necessary to keep the electrons flowing. Okay, so I want to talk about this a little bit more. We can do our net redox reaction. This one's really simple, and we've seen this before. It's going to be our copper 2 ions reacting with the zinc to have a solid copper and zinc ions. I can ask you other questions. The copper 2 ions are blue. I can ask you what's going to happen to the color of this cell as it operates. Well, copper 2 is reacting with electrons to form solid copper, so the color of this half cell is going to get paler. All right? And there's going to be solid copper forming on the surface of this electrode. Zinc ions are colorless, so this isn't going to look very cool, but the concentration of the zinc ions will certainly increase. What will be really noticeable though is that this zinc electrode is going to corrode. It's going to start looking rough, and it's going to start to disappear.